we have this expression and we're asked to factorize it completely. When I look at it, it seems long and complicated, but what we can do is to break the problem down into some easier bits. So based on the previous video, we had two terms. So what I can do is to block out the last two terms and just work with them piece by piece. This looks a lot simpler, don't it? So let's work this out. We're looking for the highest common factor between 2x squared and 6x. So I'm going to start with the numbers. 2 can go into 2x squared and 2 can also go into 6x. When I look at the letters, x can go into x squared and x can also go into x. So the highest common factor would be 2x. Then I'm going to open up my bracket now and divide these two terms by that 2x. So look, 2 into 2 goes one time, so these cancel. Remember, x squared literally means xx. So I can cancel one x at the top with one x down here. So all I'm left with would be just x. And if we multiply it back out, x times 2x will give us 2x squared. Good. Let's look at this part now. 2 into 2, 1. 2 into 6 goes 3. 1x at the top with 1x at the bottom. So we're left back with just plus 3. And if I multiply it back, 2x times 3 will give us 6x, which was what originally was there. So we're finished with the first part. So we're on to the second part now. So I can simply block out the first part and just work the second part, just like how we did it. So I have plus 5x plus 15. The highest common factor between 5x and 15 is going to be a positive 5. You see that now? So I'm going to open up my brackets and then divide both terms by that positive 5. 5 into 5, one time, so these cancel, leaving us with just x. And if we multiply it back, 5 times x will give us 5x. 5 into 15 goes one time, no, 5 into 5 goes 1, and 5 into a positive 15 goes 3 times. So we're left with a positive 3. Take a look at this. Do you notice anything that is common? Let's look at this. We have x plus 3 and we have x plus 3. Notice that these are in brackets. So these brackets are what we call groupings. So a grouping is just a bracket with at least two terms. In this case, we have x plus 3, x plus 3. So we're looking for what is common, and the brackets are common, and this will now become our new HCF. So just like last time, I'm going to pull out what is common, and this time I'm pulling out the brackets. So I'm going to have x plus 3, and I'm going to open up a new bracket now. And remember what goes inside the brackets? The answer we get when we divide all the terms by the HCF. The HCF this time is a bracket. So I'm going to put the entire bracket here and here. And then I can reduce. So this bracket with x plus 3 cancels this bracket with x plus 3, leaving us with just 2x. This bracket with x plus 3 at the top cancels this bracket with x plus 3 at the bottom, leaving us with just plus 5. So the final answer is a product of two brackets, x plus 3 and 2x plus 5. This case is a little different, but we can take a similar approach. Let's look at it. We have x squared plus 2x minus 5x minus 10. And we're going to just break that up into two pieces and work it simpler. So we're looking for what is common between x squared and a positive 2x, which is just x. And I'm going to divide through by that highest common factor of x. So x into x squared goes x. So if I multiply it back out, x times x will give us x squared. So this is good. So now we have 2x divided by x. 1x at the top, 1x at the bottom. So we're left with a plus 2. So far, we're good. Let's go over to the other side now. We have negative 5x and negative 10. What is common between both of them? We could pull out a positive 5. Watch what happens now. So I'm going to have to divide both of these by a positive 5. So negative 5x divided by 5, look at what happens. Negative 1x or just negative x. And you have negative 10 divided by 5 will just give us a negative 2. So far, you with me? Let's look at what we have before. Are the brackets the same? X plus 2 minus x minus 2. No, they're not. But we can do something. We don't need to fret. We're not going to struggle. We're going to get through this. What we can do is to apply a negative 1. What the negative 1 does is to turn things into its opposite. If you look at this, this is positive x. And if you look at this, this is a negative x. If you look at this, this is positive 2. And this is negative 2. So if I apply a negative 1 or factor out a negative 1, it can turn things around for us. So watch how we get it done. So I'm going to apply that negative 1 to the HCF and to everything inside the brackets. Look at what happens. Negative 1 times a positive 5 will give us a negative 5. See that? Negative 1 times a negative x will give us a positive x. Negative 1 times a negative 2 will give us a positive 2. And we're going to write back what we had before on the left side. So we have x bracket x plus 2. Let's check the brackets now. X plus 2 and x plus 2, they are the same. So by grouping, I can factorize these two brackets or these two parts of the expression and make it a little simpler. So the brackets are common, so I'm going to pull out those brackets, x plus 2, and then I'm going to divide both of these terms by the bracket x plus 2. Remember now that the bracket becomes the HCF because they're common between the two terms. Good. So this x plus 2 at the top is cancelled with this x plus 2 at the bottom, leaving us with just x. This x plus 2 at the top will be cancelled by this x plus 2 at the bottom, leaving us with just minus 5. So when we rewrite this expression as a product of two brackets, we end up with x plus 2 in bracket and x minus 5 in bracket. Just remember, when you see that the brackets here look opposite, applying that negative 1 to the HCF and all the other terms will help us to factorize the brackets.